Hi, my name is Adi, and I'm a software engineer at Amazon. And what I've come to understand is a lot of CS concepts seem a lot harder than they actually are. And so in this video, I'm going to try to explain to you what a GPU is in a way I wish it was explained to me. A GPU is just a bunch of CPUs lined up together. Basically, a CPU has four cores. These cores perform tasks, and they're generalist tasks, as in the CPU could be given any type of instruction set and it will just perform it. And it's really powerful because it can go from processing your videos to playing your video games to rendering up onto your screen whatever you're watching or streaming, or it can go into like training models. But it's not the greatest at doing parallel tasks that are doing simple operations over and over again, the same operations, and they don't depend on tasks before them or after them. GPUs are really good at this. For example, the NVIDIA 4090 has 16,000 cores compared to your CPU that might have 4, 8, 16 cores. But the GPU is optimized with TensorFlow cores and RTX cores, and so it can do parallel tasks like matrix multiplication for an LLM training or video processing using RTX cores, and it can do them all at once. So you get the job done faster. Think of this as you go to an artist and you say, I want to render to my screen this incredible piece of art. And these colors need to be in these places. And then the artist goes ahead and performs that task. That's the CPU. Or you could say, I know exactly where I want each piece of color that would eventually make this like whole piece of art render onto my screen. And so you go to a bunch of middle schoolers, give them a crayon each, and say, just color in this portion. The 1,000 middle schoolers, all coloring in one portion at a time, will get the job done faster than the artist who will go step by step to make the art appear on your screen. That's essentially the difference between a GPU and a CPU. A GPU is used for parallel processing work, and a CPU is used for sequential processing work. A GPU is optimized, a CPU is a generalist. One last thing is coding for a GPU is different. Coding for a GPU often uses something called CUDA, which is an NVIDIA's language, or you can work with Python and stuff, but you need libraries imported, like a TensorFlow library or a PyTorch library, which then, when your code is, turned into machine language, tells your computer, actually, this work should be performed on the GPU and not your CPU. Lastly, a GPU is really, really hot because you're putting all these cores in. So you have to have specialized cooling. That's why often in consumer GPUs, you'll have the fans on them, like two, three fans. Latest GPUs have to be cooled underwater. But that's all you really need to know. A GPU is just a bunch of really weak CPUs lined up together. Oftentimes, you'll find your GPU is integrated into your CPU and sharing the same RAM as your CPU. But if it isn't, if it's a dedicated GPU card, it'll have its own virtual RAM. That's all you need to know.